In the last episode, we learned that a large language model is not thinking. It's doing the world's most sophisticated autocomplete. Tokens go in, math happens, the next token comes out. But knowing the theory is one thing. Today, we're going to build one. From scratch. By the end of this video, you'll have a working language model that generates text, not a toy, not a demo, the real thing. Just smaller. And you'll understand every piece of it. Every language model has the same blueprint. Think of it like a recipe with 5 steps. Step 1, turn your text into numbers. Computers only understand numbers, so this has to happen first. Step 2, give those numbers meaning. A little lookup table that says, the letter A means this kind of thing, B means that kind of thing. Step 3 is the engine, a stack of identical blocks that process the text. Each block looks at what came before and decides what matters. Step 4, turn those numbers back into text. Which letter is most likely to come next? And step 5, practice. Show the model examples, check its answers, adjust, repeat. Millions of times. The model we're building today is tiny by industry standards, about 10 million adjustable knobs. GPT 5.5 has over 1 trillion. But the recipe is the same. A skyscraper and a dollhouse both have walls and windows and a roof. Same blueprint, different size. Everything starts with text. For our miniature model, we'll use the complete works of Shakespeare. About 1 million characters, all public domain, all in a single file. Perfect training material. First, we turn characters into numbers. Since we're working character by character, our vocabulary is just 65 unique characters. Letters, punctuation, spaces, new lines. Each one gets a number, A is 0, B is 1, and so on. Simple. Then we make training examples. A training example is just a string of characters and the correct next character. To be or not to, what should come next? The letter B, all the world's a, what should come next? The letter S for, stage. We do this millions of times over the whole text. Each example is baby simple. Input, correct answer. That's it. Now the interesting part. The transformer block. It sounds intimidating, but it does 2 simple things. First, it looks backward. When the model is trying to predict the next character, it looks at every single character that came before. Not just the last one, all of them. And it figures out which ones matter most. The cat sat on the word that tells you a noun is coming. The word sat tells you something Saturday. The model learns to connect all these clues. Second, it thinks about what it found. After gathering clues from the entire history, it runs them through a simple processing step. Multiply some numbers, apply a threshold, multiply again. That's honestly it. One transformer block looks backward and thinks. Then it passes the result to the next block. And the next. And the next. Our miniature model uses 6 of these blocks. A production model like GPT 5.5 uses dozens. Each block builds on what the previous one figured out. Early blocks catch simple patterns, word boundaries, common letter pairs. Later blocks catch complex ones, sentence structure, dialogue patterns, the distinctive rhythm of Shakespeare. Training is where it all comes together. It's just a guessing game. Show the model some characters. It guesses the next one. We compare its guess to the real answer. How wrong was it? That number is called the loss. Big loss means bad guess. Small loss means getting better. Then we adjust. Every single knob in the model gets turned just a tiny bit in the direction that would have made the guess better. Then we show another example. Guess, check, adjust. Guess, check, adjust. 5,000 times. And something remarkable happens. The loss drops. At first, the model produces random gibberish. Just noise. Then it learns spaces and common letters. Then short words appear, the, and, to. Then punctuation. Eventually, it generates text that actually sounds like Shakespeare. Not perfect, sometimes nonsense words slip through. But the rhythm, the vocabulary, the cadence. It learned English just by playing a guessing game over and over. Once the model is trained, generating new text is beautifully simple. Give it a few characters to start, a prompt. It predicts the next character. Then you feed that character back in along with everything before it. Predict again. Feed it back in. Predict again. One character at a time, the text grows. This is why large language models need giant context windows. The model doesn't remember anything between predictions. Every time it guesses the next character, it rereads everything from the beginning. If you want it to stay coherent for a long conversation, it needs to be able to see far enough back. Here's what our Shakespeare model generates before training: complete nonsense. And here's the same model after 5,000 rounds of the guessing game. The difference is extraordinary. From random characters to be, or not to be, that is the question. It learned the English language from patterns alone. Here's what I want you to take away. A language model is not magic. It's a 5-step recipe. Turn text into numbers. Give those numbers meaning. Pass them through a stack of blocks that look backward and think. Turn the result back into text. Then practice, practice, practice. Everything in a trillion parameter model like GPT 5.5 is present in our 10 million parameter miniature. The recipe is identical. The only differences are how many knobs you have and how much text you train on. More knobs, more text, better results. The code to build this model is about 300 lines of Python. You can run it on a laptop this afternoon. You can train it on anything: your own writing, a friend's texts, a favorite book. The model doesn't care what it learns. It just plays the guessing game. Link to the code is in the description. Next episode, we're going deeper into fine-tuning. How you take a general model and teach it to be a specialist. Subscribe so you don't miss it.